Welcome, listeners. Again, we'll be continuing with our discussion on earthquakes. So here after the discussion on that how an earthquake originate, obviously due to the presence of faults, be it along your subduction zones, be it along your mid-oceanic ridges, even along your transform fault boundaries or the strike slip boundaries that are present across different mid-oceanic ridges, also in some cases across some subduction zones. So they are always related to some kind of a fault, be it a normal fault related to the mid-oceanic ridges under tensional regime, be it your thrust or reverse fault that are associated with subduction zones under compressional regime, and also they it could be related with your strike slip zones or the transform fault boundaries. So apart from that, a consideration that is important before looking at the damages or destructions related to your earthquakes. Earthquakes can be of shallow focus, intermediate or medium focus, and as well as deep focus earthquakes. So in case of earthquakes, like again, if it is related to fault and fault, always, apart from a few exceptions, always your earthquakes are related, because there are sometimes, like we mentioned in the definition of the earthquake, that shaking or trembling of the earth is usually referred to as your earthquake. There are sometimes also some volcanic tremors during an a greater event of volcanism. Your ground also shakes or tremble during a volcanic activity, large scale volcanic activity. So those are specifically considered as volcanic tremors. So apart from these exceptions, obviously earthquakes are always and always related with some kind of a fault. So again, talking about the presence of faults, like we have discussed in our discussion with brittle structures, or in case of plate tectonic theory in our earlier discussion as well, that the upper crustal level or the crustal part, you can say, will have the upper crustal part will have the brittle regime, or the nature of structures that will form over there, including your fault and joint. They are strictly brittle structures, like we have discussed. So if I am saying that earthquakes are always related to faults, then you can simply state that means the earthquakes has to be shallow focus in nature, but it is not exactly true always. We will be talking about that in a bit. So the idea is that obviously for to generate a fault, you need to have some kind of brittle regime, unless the presence of your brittle regime, you can't really create a fault, and likewise you can't really generate an earthquake. But again, most of the earthquakes, about you can say 75% to 76% earthquakes, are shallow focus in nature. Whatever earthquake repository or record we have, out of that approximately 75 to 76% are shallow focus in nature, which has a depth of, you can say, about maximum 40 to 60 kilometers beneath the surface. Then you have the intermediate focus earthquake, which dominates about 19% of the earthquake records. So that extends up to a level of approximately 300 kilometers. Then you have the deep focus earthquakes, which dominate about 5% of the overall earthquake record. So here you can see that whenever we are saying intermediate or deep focus earthquake, you need to go more than 200 or even beyond 300 kilometers. So if it is beyond 300 kilometer, you can say that definitely that kind of thickness or that kind of depth cannot be achieved in case of a normal, be it your continental crust, be it your oceanic crust. So to achieve that kind of a depth, you have to go deep inside the earth, which you can only achieve if you are going into dive along, for example, a subduction zone. If you can go along a subduction zone, you will be very easily, you will be able to achieve this kind of depth, which is much higher than that of the thickness of your continental crust, and obviously much higher than that of the oceanic crust. So broadly speaking, again you have these three kinds of earthquakes. Shallow focus occur within the outer crustal layer of the earth. They originate at depths between 0 to maximum 70 kilometers. Shallow focus earthquakes are the most common. Obviously it is within the brittle zone of your crust, so it will induce several faults. So obviously it will be dominated by this, means following the occurrence of a fault, always it will be associated with a shallow focus earthquake. And about energy release, about 75% of the total energy released from earthquakes comes from shallow focus earthquakes. In case of intermediate or medium focus earthquake, they can occur at greater depths in comparison to shallow ones, obviously. So the depth will range approximately more than 60 to 70 kilometers, means beyond 70 kilometers, up to a level of 300 kilometers. So the energy contribution, intermediate earthquakes contribute about 12% of the total energy released during these seismic events. And talking about the distribution, the occurrence of intermediate focus earthquakes decreases rapidly with increasing focal depth within this range. So if the focal depth is increasing, obviously the occurrence of the intermediate one will decrease. So we will be talking with reference to the deep focus one. So in case of deep focus one, deep earthquakes are the most intriguing and occur at very high or significant depths. They origin at depths between or beyond 300 up to 700 kilometers. And obviously the energy contribution is about 3%, because they are pretty rare, these deep focus earthquakes, and they come from the very deeper part of the earth, and they also makes a part of the Benioff zone, which is referred to as, means similar to that, means you can say it is very similar to a zone of subduction. So if a plate, now if I think about a plate, a downgrowing plate that is subducting beneath an overriding one like this, so you can simply think of that at this level, when it is just getting subducted, here obviously it is shallow focus, here also it will induce faults, obviously it will be shallow focus, but as it goes down and down, what happens that the subducting slab or this part of the oceanic lithosphere will start to go under melting. So as we go deep and deep, a majority of the slab apart from the central part of the slab will go under some kind of melting. So what will happen if there is melting? Obviously there is increase in the plasticity, resulting in the decrease, or you can say the brittleness will decrease for that subducting slab. So as deep as you go down within the mantle, what is happening, you are losing the brittle nature of the subducting slab, which was obviously at the shallow level or before subduction it was strictly brittle. When it is finally entering into the mantle, what is happening is that you are losing the brittle character of that subducting slab, and it is becoming more and more plastic. So now when you are at the shallow level, or when you are referring to this shallow level earthquake, here your slab is not undergoing any kind of melting. So the complete slab is exhibiting a strictly a brittle nature. When you are going at the intermediate level beyond 70 kilometers, 100 kilometers, it is being melted, or partially it is going into melting. So your slab or the oceanic lithospheric of the subducting plate will go under melting. Finally at a depth of beyond, you can say 600 or 700 kilometers, or near about your 700 kilometers, what is happening that there you are obviously in the deep focus level, but there your subducting slab, apart from its extremely, you can say, internal or the interior of that particular slab, only a thin part of that slab is escaping in the melting event. The rest of the slab is going into melting. So what is happening that in case of shallow focus earthquake, when it is completely or the whole slab is not under any kind of melting, it can generate very easily faults, several faults on the subducting slab, and obviously it will result into the occurrence of your shallow focus earthquake. But as we go down a little bit more, there is melting is also going on along with the rest of the slab, which will still try to behave in a brittle manner. So obviously there will be some fracturing and faulting of that slab, and resulting into the occurrence of intermediate focus earthquakes. Finally, when you are going deep within the earth, then most of the slab or most of the part of that same slab will now go into melting, apart from a very, you can say, core zone of the slab which will escape any kind of melting, and that will still behave as a rigid material. So it will still behave as a, or it will still result into formation of brittle structures, again your fractures and faults that will get induced to the core of that subducting slab, resulting into the occurrence of the deep focus earthquakes. So now you see you have a very thick slab at the shallow focus level. So there you will get shallow level, you will get shallow focus. Once you enter the subduction zone, obviously you are going deep, but you have a relatively thinner slab in comparison to the means upper surface or in comparison to the zone of shallow focus earthquake. Obviously you have a relatively thinner one, and finally you have the thinnest one, because the rest of the slab will go into some kind of melting. So the core of the slab, or you can say that the thickness of the slab, is also getting reduced from your shallow to your deep focus earthquake zones. So that's why you get to or you get this kind of shallow focus earthquake, or the majority of the earthquakes are shallow focus because they are in the brittle one. So as you go deep and deep, the occurrence of these faults will decrease. Likewise, the occurrence of the earthquakes will also decrease. So now if I see at this zone, you will get a cluster of earthquake focus in the upper part of the subducting slab, or at the zone of your subduction like here. Then you will have a relatively lower number of plots here at the medium level, and very a few only at the deep level. So based on this, it is also referred to as the Benioff zone, based on this occurrence of shallow, intermediate and deep focus earthquakes. So the subducting slab have average deep of angles around 45 degree. It is generally lesser in case when your oceanic lithosphere is getting subducted beneath the continental one. In that case, it is below 45 in general. When the oceanic lithosphere is getting subducted beneath another oceanic plate, in that case it is generally more than 45. So there is a range of that, but average it is 45 degree. So your Benioff zones coincide with tectonically active island arcs and are associated with deep ocean trenches like that of the Andes mountain belt, where you can see directly that your Nazca plate, which is other half or the other side of the East Pacific rise, your western side of East Pacific rise your Pacific plate, the eastern side of your East Pacific rise is your Nazca plate, where your Nazca plate is getting subducted beneath the South American plate, resulting into the formation of the Andes mountain belt. So there also, if I plot the focus of all earthquakes, I will see this distribution, that majority of them obviously are shallow focus, then some of them are your intermediate focus, a few are only falling into this deep focus level. So obviously deep focus earthquake, if they are deep focus earthquake, they are extremely devastating in nature, because obviously a huge amount of stress or energy is getting released from your deep focus earthquakes in general, also in case of intermediate. But in shallow focus earthquake, the chances of devastation are relatively less because of very low magnitude of these earthquakes. So earthquake shaking may cause loss of life and destruction of property, and they can directly affect our life and livelihood. In a strong earthquake, the ground shakes violently. Buildings may fall or sink into the soil. Rock and soil may move downhill at a rapid rate as well, and inducing in such cases landslide, and landslides can also bury houses and obviously people under it. So, based on the idea of how far an earthquake can create damage, to quantify that, there are things like magnitude of an earthquake, and that is the measure of its strength. It indicates the size of the seismic wave generated by earthquake source and recorded by seismographs. The magnitude of earthquake is measured on the following scales. So there are broadly three scales. The first one that become very popular is your Richter scale. The Richter scale, also known as the Richter magnitude scale, is a method for quantifying the magnitude of earthquake. It was developed in 1935 by American seismologists Charles F. Richter and Benno Gutenberg. So, if I look at the Richter scale, they simply related with the amount of TNT explosion, that how much energy or that much energy is given up by of certain amount or quantity of TNT is comparable to certain magnitude of earthquake. So, based on that, they devised this scale. But remember, this scale is obviously, the magnitude is expressed as a numerical value, allowing us to compare the size of one earthquake with another. But remember, the Richter scale is logarithmic, meaning that each whole number increase on the scale represents a 10-fold increase in amplitude of the seismic waves. For example, an earthquake with a magnitude of 6 releases 10 times more energy than one with a magnitude of 5. So, you can see these are the you can say 10 leaps of magnitude every time, or means 10 times more energy between 1 and 2, 2 and 3, 3 and 4, 5 and 6, so on and so forth. So, if the Richter magnitude is below 1, in that case it is compared with around 20 kilograms of dynamite exploded. That is also quite high, though we can't feel it on the surface of the earth. But still, if I look at this, you can see that 20 kilograms of dynamite is not a child's play. Similarly, if I look at this a magnitude of 2, you can think about again 600 kilograms of dynamite. So, it is now getting larger. So, smallest quake people can normally feel. Sometimes we feel very minor, you can say, shaking and very minor trembling, that you can, I will not say trembling, I will say only very minor shaking. So, that is comparable to Richter magnitude 2. Then you have the Richter magnitude of 3, where it is equivalent to 20,000 kilograms of dynamite. People near the epicenter definitely will feel this kind of a quake. Then you have the 4 magnitude or Richter magnitude 4 earthquake. In that case, 60,000 kilograms of dynamite. This will cause damage around the epicenter, not very far from the epicenter, but around the epicenter. It is same as that of a small fission bomb. Then Richter magnitude of 5, you can see 2 crore, means 20 million kilograms of dynamite can cause great damages around the epicenter. Richter magnitude 7, 20 billion kilograms of dynamite creates enough energy to heat New York City for 1 year, for example. Or you can say it can obviously hit our national capital for 1 year continuously. That is obviously Delhi and means New Delhi. And you have this Richter magnitude of 8, that is 60 billion kilograms of dynamite causes death and major destruction. Like that, it happened in 1906 in San Francisco, USA. And Richter magnitude 9, there has been a very few earthquake of, or you can say the rarest of earthquakes have achieved this kind of magnitude. 20 trillion kilograms of dynamite, rare but would causes unbelievable damages. The other scale that is generally used by seismologists, means who deal with seismic waves and earthquakes in greater detail, they don't really use your Richter scale very much. They use a more specific quantification, that is moment magnitude scale, because of the reason that Richter scale is still popularly associated with earthquake magnitude, but it does not represent the actual seismic moment that gets generated during an earthquake. So, your moment magnitude scale provides a more accurate representation of an earthquake's total energy release. It considers the area of movement, fault displacement, and rock rigidity. And there are sometimes problems with the means you can say the application of these scales in colloquial terms or colloquial language. Whenever there is an earthquake, usually people or your media refers to the Richter magnitude, but that is not as accurate as that of your moment magnitude scale. So, your seismic moment can be first calculated by using the shear modulus of the rock through which a fault has moved, then average amount of slip on the fault plane, how much slip or the net slip has taken place, like we discussed in our discussion with brittle structure, that the amount of slip exhibited by a fault can be calculated in the direction of the movement. So, that is your net slip. So, your average amount of slip on the fault plane as well as the area of fault plane that has ruptured, that how much area has been ruptured due to this fault. So, first your seismic moment is calculated, followed by that your moment magnitude scale is calculated, which is equivalent to 2/3 log of your seismic moment minus a constant of 6. So, based on this equation you can have a more specific quantification of an earthquake. Then you also have this Mercalli intensity scale proposed by the Italian volcanologist Mercalli. So, the Mercalli scale measures the effects of an earthquake at a specific location. Unlike the seismic magnitude, which quantifies the inherent force or strength of an earthquake, the Mercalli scale specifically focuses on the shaking intensity. So, you can say this is the Mercalli chart, and it is based on the first one, or the Mercalli scale 1 is equivalent to your moment magnitude of around 1.5 that we have calculated from here. The moment magnitude is calculated from the seismic moment. So, it is about or below, when the seismic moment or the moment magnitude is below 1.5, it falls under your Mercalli scale. So, detected only by sensitive instruments. Mercalli scale 2 failed by few persons at rest, 3, 4 like this. If I go beyond a level of, you can say 9 or 10, then you can say Mercalli scale 10, most structures or infrastructure will be destroyed, ground will crack and landslide, large scale landslide will happen. And in comparison to that, you can have a moment magnitude scale of about 7. Then you have 11 and 12, what it refers to complete devastation or complete destruction of your infrastructure, and also great loss to your people life and livelihood. There even, you can say, large scale landslide that gets induced with respect to a Mercalli scale earthquake of more than even 9. It is extremely risky. So, obviously intensity versus magnitude, these both terms are used very commonly. So, magnitude scales measure the energy released by an earthquake, rather intensity generally measures the damage created by an earthquake. So, there could be your localized shaking. Sometimes shaking intensity varies with distance from earthquake epicenter. Obviously, the moment magnitude scale accounts for regional variation in effects, and it is adapted to specific regions. So, whenever we are talking about magnitude, it is mostly related to the energy release. Whenever talking about the intensity of an earthquake, it is mostly related to the damages and destruction related to an earthquake. So, in the past 200 years record, there have been records of great earthquakes in magnitude of 9.2, like the Great Alaska earthquake at the coast of South Alaska. Here you can see, then the one that shook our whole nation, the Sumatra Andaman earthquake in 2004, that triggered the huge tsunami and that devastated in Sri Lanka and mainly the east coast of India, and I think more than 2 lakh people or even 2.5 lakh people died because of that 2004 tsunami. And it is also, remember, it is a continuous. Since then there are, means you can say, relatively greater magnitude earthquakes are continuously happening in this Java Sumatra arc region, which extends till your Andaman. So that's a place of great concern as well. Continuously earthquakes are taking place over a few years of time. So you have to keep an eye continuously on these earthquakes, because they might trigger large scale tsunamis. Then in past there is record of Chilean earthquake 1960 in the magnitude of 9.5 that occur a little bit in the offshore region of your Chile. Then you have the Tohoku earthquake. Again, it has triggered a large scale tsunami in 2009 with magnitude of 9. So this is the Tohoku region, the eastern part of your Japan, or the Japan group of islands. Here is your epicenter. Focus you can't directly see. This is the epicenter. In case of Chile earthquake, this is the epicenter. In case of the Java Sumatra earthquake or the Andaman earthquake, this is the epicenter. In case of the Alaska one, this is the epicenter. So these are all epicentral regions. Like I was talking about, again an earthquake followed in 2012 of magnitude 8.6. Luckily it didn't trigger much of means any kind of tsunami, because it was a deep focus earthquake. So your shallow focus earthquake will have a more implication or more impact to generate your surface wave, because shallow focus earthquake is there, your surface wave can move very quickly. But if you have a very deep focus earthquake, in that case obviously body waves will penetrate through the earth. So in that case your surface wave will come up, then it will penetrate or it will travel along the surface of the earth. So in case of very deep focus earthquake, it is somehow we were lucky enough. So this was the 2004 earthquake, and this was the 2012 earthquake. So you can see the epicenters are not very far from one another, but one is on the subducting, the epicenter is on the subducting slab on the Indo-Australian plate, the other one is on the Sunda plate or on the Burmese side or the Indonesian side, you can say. So due to the deep focus nature of this earthquake, it didn't trigger any kind of tsunami. So finally, talking about tsunami, that is always related, or you can say again mostly related with respect to an earthquake, but sometimes tsunami can also get generated due to volcanic eruptions, and sometimes also related to large scale landslide. So volcanic eruption, what happens in case of volcanic eruption, when the molten lava from a volcanic island is flowing into the sea, it will obviously kind of release the heat and energy into the sea. So due to that, the sea water can get displaced from the site of the volcanic island and might reach to larger waves near the shores. So earlier we have in past we have, you can say, limited information about tsunamis, but for last few decades there have been several detailed means research and findings on tsunami. So now there are several places on earth where there have been demarcated sites of tsunami where there were some event of tsunami in the past, or there is a chance of an tsunami event in the future. So there are zones where it is demarcated now as tsunami hazard zone. So it is also mentioned that in case of an earthquake, go to high ground places or very inland, such that the sea water or the sea waves can't reach you till that level. So a tsunami begins far offshore with an earthquake, volcanic eruption or large scale landslide. The sudden movement of the seabed displaces the water above it. Although the vertical movement may initially be less than a meter, it covers a large area and the total volume of the water displaced is huge. In deep water, the wave spreads out rapidly. The wave may only, it could be 30 centimeter high at this point of time, but it can travel more than hundreds or even sometimes thousands of kilometers. per hour, and unlike normal wind driven waves, these are spaced about 100 meter apart. So and related to its formation, each wave has a peak and a trough, and sometimes the trough of a tsunami reaches land before even the peak. So obviously this is you can say a schematic representation of the propagation of a tsunami wave like this. So most tsunamis do not have a breaking wave crest, instead they resemble a fast incoming tide. They can push incredible volumes of water up to a kilometer inland, sweeping up people, trees, cars and small buildings in path. You can see examples of this here. So here obviously before I conclude our discussion on earthquake and relate it is tsunami and damages related to it, just to mention a few events of large scale tsunami like the Indian Ocean tsunami I was discussing about 2004, Tohoku tsunami again triggered by the Tohoku earthquake in 2011, then Krakatoa tsunami in your past record 1883 again, but this is mainly related to the volcanism related to your Krakatoa volcanic island. Then you can also think about the Papua New Guinea tsunami, and that a tsunami actually got triggered by an undersea earthquake. So here I would like to conclude with my discussion on earthquake and tsunami and related damages. Thank you.